Welcome to the lab session of Analysis and Design of Algorithm. Myself, Mrs. Madhu Nagaraj, Assistant Professor, Department of CSE Data Science. Today we will be discussing about the program 9, which talks about the selection sort. So the program 9 says design and implement a C program to sort a given set of n integer elements using selection sort method and compute its time complexity. Run the program for varied values of n greater than 5000 and record the time taken to sort. So how does the selection sort works? So selection sort usually follows the brute force approach where it is going to find out the all possible solutions and select one suitable solution for the given problem. So in selection sort, what we are going to do is, so we will be given with a list of elements which will be in the unsorted manner. So first we are going to divide the array into sorted and unsorted. So sorted will be the first element which we are going to select, and then the remaining elements will be the unsorted. So next we are going to compare the first element with all the remaining elements in the given array, and we are going to find out the smallest element in the complete unsorted part. So once we find the sorted smallest element, which is smaller than the first element, then we are going to swap those two elements and place the smallest element in the first position. So that will become the sorted array. And the remaining elements will be the unsorted array. So this will be repeated until all the elements in the given array is sorted. So let's see with a simple example, and we will be having one phase of sorting. So this is the given input array. So this is the index. So we have the elements 64, 25, 12, 22, and 14. The first pass, so we are going to consider the 64 as sorted array and the remaining 4 elements as the unsorted array. So now we are going to compare 64 with each of the elements, and we are going to find out whether there are any other elements which is smaller than 64. So compare 64 and 25, it is smaller. Then the value will be, or the cursor will shift to 25, and 25 will be compared with 12. So 12 is smaller, shift it. Compare with 22. So 22 is, so 12 will remain as it is because 12 is smaller. Then again compare 12 and 11. So 11 is smaller, so it will be shifted there. So now the smallest element in the given complete elements are 11. So 11 will be swapped with 64. So smallest element is 11. So next step what we will do, we will swap 11 and 64. So 11 will be in the first position, 64 will be in the last position. So now we can see that the smallest element is placed in its position first. So selection sort, always the smallest element will be placed in its position. So now this will be the sorted part and this will be the unsorted part. So in the next phase we are going to select 25 and compare with all the remaining elements. So this process continues till all the elements are sorted in the given array. So this is the given algorithm. So where the input will be the array and the output will be the sorted array in the non-descending order. So now from I0 to n minus 2. So because n minus 2, because we are not going to compare the last element again. So it will be 0 to n minus 2. So the first element is selected as minimum. So next the j value will start from I plus 1. That means the second element. So this is I is pointing here and j will be pointing here to 25. So I plus 1. Next, we are going to compare both the values, whether a of j is less than a of minimum. So here a of minimum will be 64 and a of j will be 25. So we are going to compare whether these two, which element is smaller than the other. So if j value is smaller, so as we can see in our example, so minimum will be shifted or will be assigned to the value j and both will be swapped. So this will continue till you find the smallest element. So that is how the algorithm works. So the time complexity here for the selection sort for all the best case, average case and worst cases O of n square. So now let's see how the program works. So here we are using the C program to implement the selection sort. So starting from the main function, as the main function is the entry point for any of the programs. So here we have taken 1000 elements, the array of size 1000, n and k. So clock function for starting and end time. ST is the start time and ET is the end time. And TS is the time taken, so which is of type double. And we are using the random function. First, you're going to enter how many numbers you want and you're going to store it in the variable n. Next, we are going to generate the random numbers using the rand function. So all the random numbers, so how much you have specified here in n, so that many numbers of random numbers will be generated and it will be stored in the array a of k, and we are going to print that unsorted array or the random numbers that is generated. Then we are going to start the clock and call the selection sort function. So you are going to pass the array and how many number of elements you have printed. So coming to the selection sort function, so these are the variables. So now the loop will start from 0 to n minus 1 and the first element will be sorted or given to the minimum index. Next, the J loop will start from I plus 1 and each time it is going to compare all the elements. So I loop will run for the complete each individual element and J loop will run for the comparison purpose. So this will one loop will complete once all the comparison is done. Then the I loop will be incremented for the second element, or you can say the first element in the unsorted array, and the process continues. So here you are going to find out the minimum value. Once the minimum value in the array is found, then we are going to swap it with the first element. So for that we are going to use one temporary location. So temporary location is used in order to swap the elements. So from I, you are going to place it in the temporary location. That is, then you are going to place the minimum index value in the I, and whatever is there in temp, you are going to place it in the minimum index. So like this, you are going to shift, or you can say swap the elements, that is from the first position to the minimum element or the maximum element to the minimum position. So like that we are going to swap like we have seen in the example. So once the sorting is done, you are going to end the clock and then you are going to calculate the time taken. So the time taken is calculated by end time minus the start time divided by the clocks per second. So this is the inbuilt function of the clock function, the clocks per second. Then you are going to print the sorted array. So the loop will run from 1 to n. Then you are going to print all the sorted elements which are stored in a of I. And finally, you are going to print the time taken, that is time taken ts, which is stored in the variable ts. So now let's run and see the output. So when you run the program, so it will ask enter how many numbers, that is the value which will be stored in the variable n. So I will just give 10 in order to check it. So the random numbers, 10 random numbers is generated, and next it will be arranged in the sorted manner. And also the time taken is printed. Since it is less number, so very less time is required. So the time will be very less. So this is how the selection sort works. Thank you.